Okay, I want to take you through this chapter two review. There's a lot of content here. So I'm not gonna, I already have a lot of this already worked out for you. You don't want to watch me write out sentences and stuff, but there's certain problems I will write out for you. But remember, I have all these answers in Schoology. But if you're not sure about how to do a certain problem, make sure you go to that part of the video where I'm explaining that particular problem. So here, I give you two statements. I tell you what the hypothesis is. I tell you what the conclusion is. And so we should be able to write a conditional statement. And that's where you just do the if and then. So the if part, if I'm driving my car, then the conclusion, I am listening to the radio. So everyone should be able to take this and write it as a conditional statement. The converse is where you reverse. Your conclusion and your hypothesis get switched. So you can see what I wrote. If I am listening to the radio, then I am driving my car. The contrapositive is really the negation of the converse. Okay, so we see our converse, we're just going to negate it. So if I am not listening to the radio, then I am not driving my car. Okay, so again, make sure that makes sense. And then here's another example. You can read over this, you can check your answers, but hopefully that makes sense. Okay, I need you. The only one I didn't make you do was the inverse, and the inverse is not P, then not Q. Okay, so just double check to make sure you understand that. And then some of you are still struggling with the law of detachment and the law of syllogism. So I'm asking you, I'm telling you, if possible, use the law of detachment. And with the law of detachment, we have to restate the hypothesis. So I have one statement here where I say, if you are taking a test, then the conclusion, then you will be quiet. Well, we're told, I basically say the hypothesis again. I'm just telling you that Sally's taking a test. Well, then we can conclude, since we're taking a test, that Sally will be quiet. Okay, that's the law of detachment. Okay, law of syllogism, though, is where I have to give you two statements. Okay, I have to give you two conditional statements, and the conclusion of the one must be the hypothesis of the other. Okay, so if we have, like here, we can see that the conclusion, she will say yes, is the hypothesis. If she says yes, so she says yes, we can remove that part and then write what's left over. Here, Donnie, if Donnie asks Pam, that's our hypothesis, then they will go to the prom. We just take out the part that's in common. And I see the same thing in this other one where we're told that the conclusion, I will understand how to do the problems. I see the same thing as my hypothesis. I understand how to do the problem. So I take that part away and I write this statement. If I do my homework, then I will do well in my test. And that's true. So if you do your big idea questions and you understand big ideas, you're always going to do well on my tests. So hopefully that makes sense. And like I said, you can't switch. You can't have your conclusion become the hypothesis. So some people mess that up with our quiz. Okay, so then the next part, we have another where I'm telling you to rewrite this as a biconditional. So when I have two statements. So I have if P then Q. Well, here's my P. If an angle is 180, then it's a straight angle. And then I say the reverse of that. If it's a straight angle, then it's 180. This is true for both of them. So we can write this as a biconditional statement. So we get rid of the if part. So I just wrote an angle is 180 if and only if. So it's really this. Okay, and that's what we have. We have the P then Q, then the Q then P, and I can rewrite that then as if and only if it is a straight angle. Okay, and you can read this forwards and backwards, and it's true. Okay, so then some counter examples, lots of counter examples. You can take a lot of even numbers where it's the result, the quotient is not going to be even. I just happen to pick 2. 2 divided by 2 is 1. But if you try 10, half of 10 is 5. Okay, 5 is not an even number. So there's lots of examples that you can show that it's not going to be even. Okay, the other one, use a negative number. Okay, so an integer is no decimals, no fractions, but you can use a negative number. So negative numbers can be integers. So I use -5, and you can check on a calculator. If I take -5 and square it, I get a positive 25, but then -5 cubed is going to be a -125. If you reduce it, it's going to be a -1/5, which is not positive. So again, I just came up with one example. There's lots of examples that you can use to prove that to be a false statement. Okay. Now these you need to make sure that you understand. So really, you're going to see when it's an equation, it's a property of equality. If it's a congruent symbol, technically it's the property of congruence. Okay, so just make sure there is a slight difference, but the names are the same. So if I have AB equals AB, that is reflexive. Okay, 5 equals 5, that's the reflexive. Both sides are equal to each other. Okay, for this one, we just switch. My left side becomes the right side, and vice versa, where it's the same, but then it's the symmetric property. So in this case, it's the symmetric property of congruency, okay? Because instead of an equal sign, we have a congruent sign. But I just revert. My right side became my left side became the right side, and that's the symmetric property. And then here's the transitive property for congruency. We have this in common. So if I have it in common, I can then say angle A is congruent to angle C. That's the transitive property of congruency. Okay. Here is another example of symmetric property. And again, it's the congruence, it's technically of congruency, but I just reversed them. Okay, so make sure you understand that. Here is transitive property of equality. I have an equal sign now, but we share the LM, so I can say JK equals ST. That's the transitive property. And it also works for angles. I have these angles, they're the same. So angle A must be the same as angle C. Okay, so transitive property of, I don't know why I have C. This should not be a C. It's equality. They're equal signs. So E for equality. Okay, so then we talked about the 3 types of proofs. The main proof that we're going to do, that's the 2-column proof. That's where the majority of our proofs are going to be formatted with our statements and then the corresponding reasoning. But a flow chart is nice too. Okay, flow charts are a very viable way of proving stuff. And then make sure that you at least realize that you can do it in paragraph form. Okay, but that's probably the one that you're not going to be responsible to be able to justify. Okay, but those are the 3. Make sure you realize I have lots of examples. I only listed a couple, but there's lots of vertical angles. Vertical angles are formed when 2 lines intersect. We know vertical angles are congruent. We know that 1 and 2 are the same measurements. I know 3 and 4 are the same because they're vertical angles. So you could have 3, you could have angle 4, we could have angle 5 and 7 are vertical, 6 and 8. Okay, so just make sure you can identify vertical angles. Linear pairs, they form a straight line. 2 adjacent angles that are supplementary, that are add up to 180. So 1 and 3, 1 and 4, 3 and 2, 2 and 4. Lots of examples. I could use 5 and 6. I could use 5 and 8. I could use 8 and 7, 7 and 6. So lots of different ones. You just need to make sure you find 2 pairs. Okay. So now here's some algebra. I started the last one just to show you, but make sure you realize for the first 2 at least, I'm using the idea of vertical angles. I know this angle must equal this angle, so I have a simple equation to solve for x. I can easily get my x's on one side, so I brought the 8x over by subtracting. I added 4, and I know x is 11. For the y's, so here's my y's. I have 5y equals 7y minus 34. Real easy to solve. I chose to bring the 7y over by subtracting. And then my last is the division property. So I use the division property to get an answer of 17. And then you can see my same type of problem for this one. I just used vertical angles, and I got 15 for x, 7 for y. So, but I do want to walk you through this one, and we had a big idea is very similar to this. I want to do this bottom one. So I want to do it from scratch because this was the hardest type of problem on big ideas because we don't want to use vertical angles. Okay, the problem with vertical angles, we have two different variables. So if I look and tried to set this up, I would have to actually solve a system. Okay, 10y equals 7x plus 4. I can't solve that. I would have to then set this up and then solve a system. Well, there's an easier way. We can use the idea of linear pairs. Okay, and I want to match it so that I have my y's together. So I can take this angle plus this angle. So I'm going to write that. I'll write it up here. I have 3y plus 11 plus my 10y, and I know that has to equal 180. Okay, so pretty easy to simplify the 3y and the 10y, that's 13y. And I'm going to subtract my 11 right away. So when I subtract my 11, I'm going to get 169. And then when I divide, we're going to see that y is a 13. So I know y must be 13. Okay, to find x, I'm going to set up a very similar equation. I'm going to take the 7x plus 4 plus the other angle, which is 4x minus 22, and we're going to make that 180 because, again, they're supplementary. They are linear pairs, which means they add up to 180. So I'm going to have 11x, and then this will be a minus 18 equals 180. I'm going to end up using the addition property. I'm going to add 18, get a 198. Then I'm going to use the division property. So I'm going to divide by 11. And when we divide by 11, we get a nice 18. And you'll have a calculator to help you divide. Okay? So in this, I just asking for x and y, but I could easily figure out the measurement of the angles. So if I wanted to know what my big angle is, I can replace that y with a 13 and know it's 130. And I also know that then this would have to be 50, but if I plugged in an 18, 4 times 18 minus 22 is also a 50. Okay, so just make sure you understand a problem like that, so because you will see it on your exam. Okay, now I will still allow you to use the 7 postulate papers. Okay, so we have this little cheat sheet that has all the different postulates when it comes to points, lines, and planes. So it's just a matter of matching. So we should know that anytime I have two planes that intersect, they intersect and form a line, we know it's the plane intersection postulate. Okay, that's my 2.7 postulate. Okay, here we want to make sure we can read a description and then make a diagram based on it. So I am intersecting two segments, so segments D and E and segment F and G. We're told that they intersect at H, and we have H being a midpoint. So if H is a midpoint, it forces these to be the same. So use the slash mark. So I know if H is a midpoint, it's cutting my segment in half so that DH is the same length as HE. Okay. Same thing for the segment FG. This is the midpoint of both. So midpoint of both segments. I now know that from F to H has to be the same as H to G. So use two slash marks to prove that these two segments are equal to each other, congruent to each other. Okay, so then I have a line. So line AB is going to bisect segment XY. So it doesn't have to be perpendicular, it just has to bisect it. They don't tell us where it's going to, they don't have a name for it. So we just have somewhere it's going to cut this into two congruent segments. Okay, here's our first proof, and you have that proof sheet with all the reasons. Okay, so use that as your guide, and I'm hoping that you can see the flow. All the statements were already listed. We just need to be able to justify everything. Okay, so they tell us that AC equals BD. That was given. Okay, then I'm hoping that you realize you are allowed to add the smaller segments. So I know this big segment, A to C, is nothing more than taking AB plus BC. So that's what I'm showing here. That's the segment addition postulate. Okay, then you have to recognize, okay, what's the difference between step 2 and step 3? I'm hoping that you see that AB plus BC, they're the same, and all we did was we replaced. Okay, we see that this AC really is the same as BD. Okay, so I would allow you to say transitive property as well. Okay, we have something in common, so I could just use the transitive property, but you can also think of that as substitution. Okay, so then they show us that BD, so this segment, this longer segment, is nothing more than BC plus CD. And then we do the same thing. We're going to substitute, we're going to replace, so that we now know that AB, so I'm replacing the BD with AB plus BC, and it's going to equal BC plus CD. You can see that. That is, again, substitution or the transitive property. Either way, whatever one you prefer for that, I would accept. And then almost finished, we can get rid of the BCs. We can subtract BC on both sides of my equal sign. That's just the subtraction property. And what you're going to see is when you do that, you're left with AB equals CD. We're going to use the fact that it was given. We're told that EF is the same as CD. And now, once again, we could, again, call the substitution, but here I chose to use the transitive property because both are equal to CD. If they're both equal to the same thing, then I can state AB is the same as EF, and that's what we wanted to prove. Okay, so again, we have to be able to justify all the steps. And the more you do, the easier it's going to become. Okay, so here's another similar one. The good news is they gave us the first two steps. So then they're telling us for step 3, we're going to use the substitution property. So I wanted you to just see that I replaced the BC with CD. Okay, we're told that BC is the same as CD, so we wanted to replace it. And the reason we wanted to replace it is we're going to be able to show then that they're going to be equal. So the fourth step, we are just showing that, and they did it 2 in 1. So I could have broke this up into 2 steps, but they're showing that you add AB and BC, it's going to be AC. And if you add the CD and the DE, that's going to be from C to E, that length. And that's just a segment addition postulate. But then we're going to be able to see, hey, I have CD plus DE, which was this. I have this. We can now replace. The AC is really this. The CE is really this. Since they're equal to each other, I can then just substitute. I can replace. I can replace that with AC. I can replace this with CE. That's the substitution property. And now I have one last move. Since the segments are equal to each other, the measurements of the segments are equal to each other, I can then say they are congruent because that's what the definition of congruency means. If segments are equal, therefore they are congruent. Okay, so your last reason is the definition of segments. Okay, here I'm not going to spend much time. I feel very strongly that students know how to solve equations and to be able to justify the moves. So this is really the only type of proof that you can do from scratch, okay? That you won't need any hints. You should be able to go through an equation and show all your work and to justify all the steps. So you can see what I did. And then same thing for this proof here. We use the distributive property, we simplify, we add, we divide, and we can justify the answer. Okay, so I feel very confident with those type of proofs. Okay, here's a flow chart. Okay, so this one's a pretty easy proof. We're told that AC is really nothing more than AB plus AB. That is given. So first is given, and then I'm going to then show that AB plus BC equals AC. That's a segment addition postulate. And then from there, I'm able to use the transitive property. Notice AC is in common, so we can remove the AC and by the transitive property say that AB plus BA equals AB plus BC. And then it's really easy to get rid of the AB by subtracting, and there's my proof. Okay, so that one should be very easy to match, and expect to be able to do that on a test where I will just simply have you match the reasons with the statements. Okay, so you can follow this one as well. Okay, this one we're told, we're given that these two angles are equal. This is very similar to what the segments were. So we're going to be able to use the angle addition postulate. I can add two smaller angles together to make up a bigger angle. So we use the angle addition postulate. Then I can substitute. Okay, so once I see that, I can replace the 3 with angle 1. And then we switch them around. So the commutative property for addition is when I change the order. Okay, 2 plus 3 is 3 plus 2. So I did that with my angles. I wanted angle 1 first, then angle 2. And then I used the addition postulate again. And then we can end with the transitive property. So once we can show that, hey, this is really 1 and 2 added together. This is 1 and 2 added together. Therefore, these angles must be equal. Okay, so if this angle equals this angle equals the same thing. Therefore, the angles must be equal. So there's the justification. One last proof using linear pairs. So we have a postulate that says if we have linear pairs, the definition, the postulate says they have to be supplementary. They have to be able to equal 180. Okay, so as soon as I'm told that they're linear pairs, I know that they must be supplementary. Okay, we're told that in that postulate. So there's your reason. And then if they are supplementary, by definition of supplementary, we know the two angles must add up to 180. And if I have these equal, they both are equal to 180, then I can use the transitive property and say that angle 3 plus angle 4 has to be the same as angle 5 plus 6, and that's what I wanted to prove. Okay, that's, again, the transitive property of equality. Okay, so hopefully that makes sense to everybody. Okay, let me take you through this next proof. Here's where we may have to write the statement or we have to write the reason. So we're told we have a right angle. Okay, so that's what's given. I am telling you, and I can tell by this symbol that this is a right angle. So first justification, the first reason, it's a given. As soon as we know that this is called a right angle, we also then will know that it's equal to 90 degrees because that's the definition of a right angle. Okay. Then I tell you to use the angle addition postulate. So you want to show that angle EFH, so this angle right here, plus HFG, those two angles added together has to be the big angle, which we know is a 90-degree angle. So we're going to know that it's going to equal 90, but you want to show that the two smaller angles will add up to the bigger angle, and that's the angle postulate. Here, we know it's 90. We can use substitution. We know that EFG is equal to 90. We're told that it's a right angle. So we know it's 90 degrees. You can use substitution or the transitive property. So it's up to you which one you want to state. So then all we did, we then substituted. We now know, we can see, I actually named this. So we can replace EFH with 2x plus 2. So I'm just replacing, I'm substituting. And then the rest of it is just solving a simple equation. So once we substitute, we can simplify, we can add like terms, we can subtract the 3, we can divide, and we prove that we get a 29. Okay, so that's the steps. It took us 8 steps to be able to prove that x is 29. Okay, so then this section, pretty easy, but I need you to realize I'm actually stating the hypothesis second. So just with our English language, we have to realize the ground will be wet if it rains. So if it rains is our hypothesis. That's the P. Then we can state that the conclusion that will be the ground will be wet. So just make sure you realize that's P, that's Q. Same thing here. I have the if. So the if part comes second. So when I write it as a conditional statement, I need to say, if it is Monday, if P, then we have yoga. Okay. And then finally, the word whenever, we're saying, if it is sunny, that's our hypothesis. Then the conclusion, I will run 5 miles. Okay. So again, make sure you can reason that out. Here's another equation, basically an algebra proof that's, disguised as a geometric proof, but hopefully you like these kind, okay? So we're told we have a straight angle, that's given, and so since we have a straight angle, I know ABC, this flat angle right here, this straight line is 180. I can use my angle addition postulate, AB D plus DBC, I know that's going to have to be my big angle, which we know is 180. Okay, so we use the angle addition postulate, and then we substitute. We can replace this with 180, and notice right away we simplified. So we added these. So we substituted, but then we wrote 11x plus 8x, which is 19x, and then we combine our numbers, which is minus 10. We know it's 180. Again, that could have been spread out through some more steps, but hopefully you understand that we added and just wrote step 4, already simplifying. And then all we did was we did the addition postulate, or excuse me, the addition property where we add 10 to both sides. And then the last move is to divide. So the division property of equality. So anytime, whatever you do to one side of the equal sign, as long as you do it to the other, it stays balanced. But we were able to prove that we got 10. So hopefully those type of proofs make perfect sense. Okay. So then this one, you need to stay the one that you cannot assume from the picture. So what we can assume, even though it may look that, hey, it looks like PQ is the same as QT without little slash marks, like little tick marks, I don't know that they're congruent. I can't assume that they're congruent. Okay, but I can tell that PQT are all on the same line. I can tell that this is a straight line, PQT. The angle is a straight angle. The only thing we can't do is say that they're congruent. Okay, so then number 3 is another set up the equation with vertical angles. 9x plus 2 must equal 65, and I trust that everyone knows how to solve a 2-step equation. Subtract the 2, divide by 9, and you know what x is. Okay, so then I did repeat. I still want you to get all these answers. I made you do some more conditional statements. So snakes are reptiles. If it's a snake, if animal's a snake, then we know it's a reptile. Okay, so then here you just have to be careful. The if part comes second in this statement. So I take Tylenol is really the conclusion. The hypothesis, the P part is I have a headache. So if I have a headache, then I take Tylenol. Okay, quick counter, lots of examples where if you have a multiple of 5, doesn't necessarily mean that the number has to end in a 5. Okay, 55 is a multiple and it does end in 5, but there's lots of examples like 10, 20, 30, 40, 50, 60, all multiples of 5, but they end in 0. Okay, so just make sure you understand this. Here, I tell you what P is, I tell you what Q is. I ask for the converse. So remember, converse, you switch. Okay, if it's the weekend, then it is Sunday. Okay, then I ask for the inverse, where you negate the hypothesis, negate the conclusion. You can see what I wrote. And then finally, the contrapositive, you're negating the conclusion. So if not the conclusion, so in this case, if not the weekend, then it is not Sunday. Okay, so just again, make sure you understand that. I still have those up on the board. So make sure you understand that. And then we're told, try to use the law of detachment, and I can use the law of detachment if I restate the hypothesis. And that's what I do. Say, if it's hailing, then you are not going outside. Well, if I tell you it's hailing, then you're not going outside. Okay, so if I mention the conclusion, though, you can't use the law of detachment. Okay, and then for number 9, I tell you, here's my first statement. If it is December, then it's cold. There's my conclusion. But then I start with my hypothesis is the conclusion of the first statement. That's what we're looking for the law of syllogism. I take that part out, and then I can write a new statement. If it is December, then I wear my coat to school. Okay, that's using the law of detachment. Okay, for number 10, you did a problem very similar to this earlier on in this packet, but I want to make sure you really understand it. AB is a segment. So I'm going to draw my AB segment. Then we have another segment, CD, but we're told that they intersect in a way where E, where they intersect at E, is going to be the midpoint of both segments. So when I draw my CD, so again, I don't care how long this is, I'll make it like this. And this will be CD, and then we have E right here in the middle. So, but you need to show the tick marks. You need to show that this E is the midpoint of AB, which means AE is congruent, is the same length as EB. And it's also the midpoint for segment CD, which means from C to E is the same distance from E to D. Okay. And it looks like it's not drawn to scale, but by showing these tick marks, it's letting someone know that these segments are congruent and these two segments are congruent. Okay. So then the next question we saw before, but we want to make sure you realize there's 2 column proofs. That's my favorite. Then we have flow charts. And then we can have a paragraph. So just make sure you realize that there are 3 types of proofs, 3 styles of proofs. Okay. Here, we've done this many times in Big Ideas. We see that we're using the symmetric property. Okay. Symmetric property of congruency. Okay. And these are segments. So segment congruency is where I just reverse. My left side becomes the right side. My right side becomes the left side. That's the symmetric property. Okay. Here's the reflexive property of angle congruency. We're not using an equal sign, we're using a congruent sign. So this is the proper name for it. We recognize that it's the reflexive. Okay. For this one, lots of vertical. So again, we've seen this problem before, but I wanted to do it again so that you really can understand what vertical angles mean. So 3 and 2 are vertical angles. 5 and 8. So let me use my angle symbol. So angles 5, angle 8, I could say 7 and 6. I could add 1 and 4 to my list. There's lots of different angles that are vertical angles. angles. Okay, then as far as linear pair, I need two adjacent, so next two angles that add up to 180. Okay, that's what it means to be linear. They're supplementary. So I can look at 1 and 3. I can look at 5 and 6, and a whole bunch more: 6 and 8, 7 and 8, 5 and 7, 3 and 4, 2 and 4, 1 and 3, which I already said, but lots of different linear pairs of angles. Okay. Next page, we want to make sure we understand these type of problems. And for this particular problem, we can't use vertical angles, because if I tried to use and set up an equation using vertical angles, because we know vertical angles are equal to each other, unfortunately, we would have a y and we have an x. So if I use this, I have an x here and I have a y down here. They don't mix. So what you want to make sure that you understand then is you're going to use linear pairs. Okay, you're going to take your y's. Actually, let's find x first. We'll take this equation, or this angle that has an x and this angle with an x, and we're going to add them together. So 6x plus 77 plus 4x plus 43. And we know they are supplementary. They're 180. So this should be very easy to solve. We're going to end up getting 10x. When you add, you're going to get 120. And then I'm going to use the subtraction property. And then finally, the division property. So I just have to divide by 10. And just like that, I know that x is 6. Okay, now I'm not asking you for the measurement of the angles, but if I did, all you would have to do is plug in a 6. 6 times 6 plus 77 would be your answer. Okay, but I do need to set up the problem to find my y. So I look at my two angles that are linear pairs with a y, and I add them together. So 2y plus 41 plus 5y plus 48, and that's going to equal 180. I combine like terms, and then I'm going to use my subtraction property. Again, you can use a calculator. You need a calculator for this. 180 minus 89 is going to be 91. Oh, why did I write a 5? Sorry. 2y plus 5y is 7y. And then my last move is the division property. I'm going to divide by 7. 91 divided by 7 is a nice 13. Okay, so make sure you can do that. Okay, so then here is an algebraic proof. These are super easy. Let me rewrite the equation. So on your test, I would have you rewrite the equation. That would be the given. Then you're going to just clean this up. You can do the distributive property first, which is 15x plus 3 equals 13x plus 5. And that is the distributive property. Okay. Then what we're going to do is we can use the subtraction property, and I'm going to do it twice. So I'm going to show you right away that we can subtract a 13x and I can subtract a 3. So for my step 3, I'm going to end up with just a 2x equals 5 minus 3 is 2. So I got rid of the 3 on this side. I got rid of the 13x by using the subtraction property of equalities. So subtraction property of equality. Okay. Then the last move, we just simply have to divide. So if I divide by 2, I'm proving x equals 1. So my fourth justification is the division property of equality. Okay. So then here's a proof. We just need to fill out the reasons. So we're given that 1 and 2, we're told 1 and 2 are linear pairs, and that 2 and 4 are vertical. Okay, we're going to prove that you add 1 and 4, and you can see that that's a linear pair. You can see from the picture that of course it's going to add up to 180, but we want to be able to justify all the steps. So they have a flow chart here. This was given. Then we see that 1 and 2 are supplementary, and that's reason number 1. And the reason we can say that is there's a postulate that says that. Okay, we were able to show that in our notes that we have the linear pair postulate. Oops, postulate. Okay, we know that if they are a linear pair, we know that then they have to be supplementary. Okay, and if they're supplementary, then I know that the two angles, so I know that 1 plus the measurement angle 2 has to be 180 degrees. And then they tell us the reason. So we're able to go from supplementary to being equal to 180 because that's what it means to be supplementary. Okay. Then here, for reason number 3, I am told that 2 is congruent to 4, and we know that because they are vertical angles, and we have the vertical angle congruence theorem. Okay, we proved that in class that if we have vertical angles, we can then say that they are congruent to each other. That is a theorem that was proven already. And so the definition of congruency means I can say that they're equal to each other. So if angle 2 is congruent to angle 4, then I know whatever the measurement is of angle 2 has to be the same as the measurement of angle 4. That's the definition of congruency. And then what we can see is we can just simply substitute. So to be able to then go from here, I can replace, and I'm just simply substituting in my numbers. So I can justify step 5 by using the substitution property of equality. Okay, so again, this is a pretty easy proof to be able to show. So the main thing you wanted to see is from this statement, so just so that you can see, I have measurement of angle 1 plus the measurement of angle 2. Well, measurement of angle 2 is really the measurement of angle 4, so that's, again, the substitution you need to be able to see. I can replace this angle 2 with an equivalent, which is angle 4, for my conclusion, my proof. Okay, so substitution. You could also use the transitive property. Okay, so if you wanted to, you could say the transitive property. Okay, last page. And we have 1 or 2 more proofs that we can go through pretty quickly. So I am telling you that we bisect. Okay, we are bisecting, and we're going to know then that these two angles are congruent. So we're going to end up proving that twice the angle equals the big angle. Okay, so that's what we're going to hopefully be able to prove. So step 1, we're looking right here. We're told that this bisects, and then therefore we can say, because of the definition, as soon as I know it bisects, it divides it into 2 equal parts. So I know definition of angle bisector. Okay, we were introduced to that, a bisector, in chapter 1. Okay, and since they are congruent, I can then say they're equal. Definition of congruency means that this congruent symbol can be replaced. So it's the measurement of A, B, D must be the same as the measurement of B or D, B, C. D, B, C. Okay, that's just simply the definition. Okay, then I'm hoping you realize you can add the 2 smaller angles together, and that's simply the angle addition postulate. So angle addition postulate. Okay, so we have that. And then step 4, realize I can simply substitute them. I can replace. So to be able to go from these two statements to this is simply substitution. And it's a property of equality. And then from this statement here, what I'm hoping that you're going to be able to see is we can use the distributed, it's really the distributed property in reverse. Okay, so I just need you to realize that we are simplifying this. So notice we have the same thing. Okay, we have the same thing to make it 2. I would accept simplifying, but how our book and the real reason they want this to be the distributed property, really in reverse. Distributed property of equality. So let me show that in a little bit better way. If I have 2 of the same things added together, it's really factoring out this angle, and I have 1 plus 1. And 1 plus 1 shows that it's the 2. Okay, but I'm hoping it's very similar to x plus x is 2x. But you can apply that to angles. But again, the official reason is the reverse of the distributed property. So it's still considered the distributed property in reverse. Okay, last proof. And this one is pretty straightforward. We have all the reasons at the bottom. We just have to match them up. So obviously the given is going to be G. Then I'm hoping that you realize we're using the segment addition postulate. When I take AB and BC to equal AC, we know that that's the segment addition postulate. And we do it again. So same thing to be able to take a CD and the BC to equal BD. So it's the segment addition postulate again. So another E. And then we use the transitive property. So what we need to see is we have that in common. Okay, so since this is in common, I can say AB, I can do the AB equals BD, which is really going to be this. Okay, so BD equals this. So it's the reason is the transitive property, which is A. Okay, then I'm hoping you can see all we did from step 4 to step 5 is we subtracted the BC. We got rid of the BC by subtraction. That's the subtraction property, which is F. And finally, if they are equal, if 2 segments are equal, then because of the definition of congruency, we can say that the 2 segments are congruent, and that is AC. Okay, so make sure you can force yourself to see what's going on. And like I said, for this step here, realize it also is substitution. Okay, so you can also think of this as being substituting instead of just the transitive property, but they go hand in hand. Okay, so hopefully you checked all your answers. You can reason out each step, and you're getting better at recognizing the reasons and the statements. Okay, thank you for watching.